Hi guys, welcome to Mathland TV. This is 3-6 recursive formulas for sequences. It seems like a couple will always have a hard time with this section, and it does show up over and over and again. So if you have any questions, you make sure you ask me tomorrow in class. Here's your journal choice. Here's some pictures. Get it? Formula. Those are formula. Okay. And I wrote that in cursive because cursive's in the word too. I hope you appreciate the thought and effort I put into that. Where can I go to the next slide? This needs to go away. There it goes. Okay. Objective and what's the point? We're going to talk about recursive formulas today. It's not going to be the first time you'll see this. It will be the first time possibly. It won't be the last time you'll see it. You'll see it lots in the future. And we're going to, it says introduce explicit formulas, but we've talked about explicit formulas already in Chapter 1. We are going to model situations with recursive formulas and evaluate them. And this is what you're going to find about this one. These formulas are very, very easy to write, but they stink to use. So sometimes kids prefer to use this if I say write a rule or a formula for this sequence that all want to write recursive. But you'll see in the long run it's not the best to use if you're looking for that mystery term. Here are your notes. Okay. A sequence. Do you guys remember what a sequence is? It's that pattern. We list it out. 2, 3, 4, 5, ... or maybe 5, 10, 15, 20, ... If you remember, it goes on forever. It is a discrete function because when you graph it, this was term 1, term 2, term 3, term 4. We graph 1, 5, 2, 10, 3, 15. We did this in Chapter 1. Okay? When you plot it, because it is discrete, it looks like graphs. Okay? It looks like dots, excuse me. Explicit formula was a rule that we used that showed up on your test, and maybe it looks like this. Tn is 100 minus 4n. And I could ask you, what is the 100th term? And you could plug in, oh, T100. And you could quickly get what that term would be, 100 minus 4 times 100. You'd say, oh, Ms. Bruno, it's negative 300. It's very helpful, or you could, if you needed a bunch of them, you could use a table. Most of you did very good on that in Chapter 1. A recursive formula is another way to write it. Okay, it doesn't look like this. A recursive formula has two parts to it. Okay, it is a set of statements used to generate a sequence. It starts with the first term, or first few terms if it was necessary. Then the second statement tells us how to relate the next term to the previous term. Okay, like I said, it's easier to write than an explicit formula, but it takes much longer to use. It is convenient to use a calculator when generating the list of terms from a recursive formula. Okay, here's how it will look. Maybe we say, we could do this 5, 10, 15, 21. T sub 1 equals 5. That's that first rule. The first term is 5. Now what we do is we say something like T sub n equals, that means the mystery term, that mystery term where we can plug stuff in there. We might say is the one before it, T sub n minus 1, because that term has to be before T sub n, because T sub n minus 1. So if this is T sub 100, this would be T sub 99. And what am I doing each time? What is that rule? Well, each time I'm adding 5 plus 5. This is saying, hey, this sequence starts with 5. And to find that mystery term, you go to the one before it and you add 5 more. Okay? You do have to write what the domain is, and it'll always say 4 integers. And then we'll say, when can we use this rule that I wrote down? Well, what's the first n I could plug in here? I don't want to plug in 1 because 1 was already used. So we say for integers n greater than equal to 2, or you could put for n greater than 1. Those are your options there. I always say, because there's 4 parts. There's the first part, what am I starting with? What's the rule? 4 integers, because remember we can't plug in half terms, and then this part. 4 parts. This is super fun. I hope you like it. Crapsicle. Okay, here's some practice. The NCAA women's basketball tournament originally consists of 64 teams, which are paired in single elimination contests. At the end of each round of play, the number of teams proceeding to the next round is half the previous number because half the teams get beat, so half the teams lose. This is the sequence at the beginning of round N, so it starts with 64. So use words to write this out. How could we write this out with words? Well, you could say the tournament starts with 64 and each day it's cut in half, or it's multiplied by 1/2, or divided by 2. Here we go. The first term is 64. Each of the following terms is found by dividing the previous term by 2. Here's how we can write. There are options here, and I almost always do this one. In fact, I always do that one. I do not do this one, but this is an option. Okay, here we go again. What is the first term? Oh, guess what? We're starting with 64. Then, what is the mystery term? Sometimes I call it the mystery meat term. It's 1/2 times the term before it. Okay, you could have also wrote b sub n minus 1 divide by 2. It's just not as nice looking, so we prefer it to do this way. Now, this sequence does not go forever. And I could see if somebody put 1 there, this one would be optional. Okay, so what numbers can I plug in here? Can I plug in 2? Yeah, there's a second term. But this one ends at term. This is 1, 2, 3, 4, 5, 6. This term ends at 6. So we say for integers n equals this, or you can say for integers 2 less than equal to n less than equal to 6. Okay, how is that different than this one? Okay, this is saying the first term is 64. The term later on, n plus 1, is 1/2 of the one before it still. But when you decide what to plug in here, your domains are going to be different. Because what's the first number I can plug in for n here is 1, because that gives you that second term, and that's the second term we're looking for. Whatever works for you, use it. Okay. Suppose that we expanded it to include 128 teams, so now we're looking at 128, 64, 32. This isn't going to change everything, because now the sequence has 1, 2, 3, 4, 5, 6, 7 terms. The recursive formula will look like, what is the first term? 128. What is the rule to get the mystery term? Well, it's still the same, 1/2 times the one before this one, which is t sub n minus 1. 4 integers. We have term 2 we can use. And we can go all the way to term 3, 4, 5, 6, 7. Okay, this is just like number 6. That'll be on your homework that you have tomorrow in class. So you might want to jot that down. What are the first 5 terms of this sequence? And then we're going to write the recursive formula. The first term is 4. Each term after that is negative 1/4 times the previous term. Okay? So this is easy. The first term, you could write it like this, T1, T2, T3, T4, T5 if you want. Well, the first term is 4. Each term after this is negative 1/4 times this. So 4 times negative 1/4 is negative 1. This is negative 1/4 times the one before it. So now I have negative 1 times negative 1/4. This is positive 1/4. Now we had the one before it times negative 1/4. 1/4 times negative 1/4. Negative 1 over 16. Negative 1 over 16 times negative 1/4 positive 1 over 64. What would this recursive formula look like? T sub 1 is 4. The mystery term is negative 1/4 times the one before it. Now technically there's no limit to this one, It could go on forever and ever and ever. So I'm going to say for integers n greater than or equal to 2. Okay, now I told you that these are easy to write because they are easy to write. They're very procedural. What's the first one? What's the mystery one? For integers, then how big is it? But why these stink? If I ask you right now, this is your formula. Hey, what's the 100th term? There's no shortcut. I cannot find the 100th term without knowing the 99th term. I can't find the 99th term without knowing the 98th term. You have no choice but to list them all out. Okay? And you guys could have done that without writing this rule. So these are not good for finding those terms that are late in the game. Okay, but they are fun to write. You might not think they're as fun to write as I do, but that's okay. Okay, it says page 16, there's a nice little table on page 187, excuse me. Number 16. We're going to describe in words. We're just going to do it. Let's just go to this problem here. The table on the right gives the cost per book of printing 100 or more books based on the number of color pages in the book. Okay, so we're like talking about a yearbook or something. Describe in words a sequence that gives the cost per book for books with n color pages. So how can we say in words? Well, I need a different color. The first book is $5.55 with one color page. Every book after, I shouldn't say first book. Let's start over. I should say to print 100 books with one color page is $5.55 per book. For each additional color page, you add how much? 55 to 70, 65, 70 cents. Sounds like 15 cents to me. Does that trend continue? Yes, it does. You add 15 cents. Or you could say 15 cents per color page. But you needed to give them that starting point. Where are we starting at? What's that initial cost before you get the recursive rule? So how do I write the formula? Well, T sub 1. You could use whatever letter you want. I almost always use T. T sub 1 is $5.55. The mystery term is, that's horrible. My computer's slow too. Oh, big eraser. Hello. T sub n minus 1 plus 15. Technically, you could have as many color pages as you want, I'm sure. N greater than or equal to. I already used 1, so I'm just going to 2. There's the 4 parts. That was really sloppy. Oh. Where do we leave off? Okay, these are some notes for the homework we'll talk about tomorrow. Look, these aren't so bad. I was talking about the problems, not the piece. Okay, a little funny. I'll see you tomorrow. Goodbye.